Next up, I'm gonna show you how to solve the ALEKS problem, drawing the Newman projection. So what ALEKS is gonna do here is it's gonna ask us to draw the Newman projection so that it corresponds to the molecule and conformation shown when viewed down the red bond in the direction of the arrow. So what you want to picture here to solve this one is that you have a carbon here on the left-hand side of the red and a carbon on the right-hand side of the red. And attached onto those carbons, you have three different molecules attached. So say to the left right here, this is carbon left, you have a fluorine, you have a CH3, and you have an H. Next up, my tips to solve this question are as follows, and I'll use my picks to help explain, but the solid line means that it's on the plane with the molecule. The dash means that it's headed towards the back. The solid wedge line means that it's coming out the screen and towards you. And then for this question, I like to use the solid line to indicate which model to pick from right here. So I use the solid lines to dictate the directions, and I'll show that. And then also, instead of writing CH3, if it's on the left hand side, you're going to write it as H3C, and the reason being is because it's on the left and it kind of goes out towards this way. If you was to write CH3, I'll kind of write an example like this. You used to write a CH3, that means that the line here would be connected to the hydrogen instead. So if I was to erase this and write it the other way, which is like the way that ALEKS like to see it when it's on the left hand side, you're going to write it as H3C. And that way the line is going to be connected on the carbon. So again, if you have like a molecule or so that's listed on this left-hand side, so right here or right here, you're going to write it backwards. So if it's on the wedge, you're going to write the compound backwards. That's the way that ALEKS like to see it. So when it comes to the molecule itself, just remember some of these key tricks. If it's on the solid line, it's either going to go towards the top or the bottom, specifically for this question. If it's on a dash line, then it's going to go to the left-hand side. And if it's on a wedge, it's going to go to the right, and it's going to be written as normal. Now, the carbon that's on the left-hand side, and I'll just put an L so you can imagine, but just picture the carbon on the left-hand side are all attached together. Are these three compounds that's on it are all attached. So this would be an L, or this would be considered on the left. This line right here is on the left, and this line right here is on the left. So I put three L's to kind of indicate that it'll be these three molecules, and then the other compounds in it is going to be on the right-hand side. So I have my stick and ball model just to kind of show you. So the compounds that's in yellow right here in my model kit, those are considered on the line and on the plane. So as you see, they're not coming towards you, are really away from the screen, versus the lines on the white are the hydrogens. They're considered to be on the wedge. So as you see, they're coming like towards the screen and towards you. And then the oxygens that I have here in red towards the back, those would be considered on the dash because it's considered going backwards. Now let's solve the question itself. So with this, I look at the projection, and I usually draw a up arrow. And kind of going back to my model real quick, this is kind of depicted of how it is. So you start with your picture. Picture this bond right here is what's in red, and that I pick up the molecule if I could, and I turn it right. And once I turn it right and I place it down, this is how you'll see. So it kind of matches up with the answer of how we're going to go about this question. But this is how I picture like my final molecule at the end. But first, coming to the compound itself, I usually draw up arrow, and I pay attention to my two solid dash lines only. So in this case, this H3C, I'm going to just put a little X right here. And then I have another dash line right here, CH3, and I'm going to put an X right there. Next up, I want to focus on the direction that those, just the solid lines are going. I see with this CH3, this is going upward, so it's going in up direction. And then this other CH3 right here, I see that it's facing downward, so it's facing a down direction. So with this, when I look at my little screen, and I can see which model that I want to use to solve this, because I have one that's going up and one going down, it correlates with this one right here, because you have it up like the carbon on the left facing up, and then you had the carbon on the right facing down. So next up, I look at what compounds are on it now that I have at least my main one identified, and then I just work to solve it real quick using the basic rules that I put out already. So on the top, I see that I have CH3. And again, as I mentioned, unless it's on the left-hand side or on the dash, you're going to write it as such. You're going to write it normal. So even though it says H3C, you're still going to write it as CH3 because the line's going to be connected to the carbon. Next up, because I have a dash, I see I have a fluorine on the dash. And as my rules mentioned, if it's on the dash, it goes to the left-hand side of the compound. So because it's on the dash, I'm just going to put it on the left, and I'm going to put it on this connection showing the left carbon. So because they're all kind of connected together. And next up, I see I have a hydrogens, and I'm going to put the hydrogen on the right-hand side as such. And it's still on the line where the carbons are all pretty much on this little structure right here, where it goes out in this direction, and this direction. Next up, I just see what I have left. I go to my carbon that's on the right-hand side, and I see that I have a CH3. So it's going to be the same rule that follows. I'm going to take my CH3, and I'm going to place it on the bottom carbon. And then on the dash, I see that I have a hydrogen. So I'm going to take the hydrogen and I'm going to place it on the left-hand side. So it'll be placed right here. And then the last one I have on the solid wedge line, I have OH. So from here, I'm just going to place that solid OH right there. So again, it's fairly simple. You picture yourself picking the compound up, and then you're laying it flat, and you're just picturing where it goes. Your carbons that are on the left-hand side will be on this little line structure as I circle right here on the inside, and you just match everything where it goes. So if it's on the dash, it's going to go out here to the left-hand side. If it's on the solid, or if on the solid wedge line, it's going to go out here towards the right. And then if it's on just the regular solid line, it's going to go up. So that's it for this one. And then I'm going to show you another kind of different example that you possibly might see in ALEKS. So right here is another version of the way that ALEKS might ask the question to you. And what you want to look for with this one is still the same rules, except you already have an up arrow this time. So you want to focus on those that are on the solid lines, or those molecules that's on the solid line. So I'll just circle this one right here and this one right here because they're on the solid line. And what I noticed that's different from the last one is that the one that's on the carbon on the right is facing up, and this one right here is also facing up. So because they're facing up, that means that they're going to be close together versus when in the last example, one was facing down. And so because of this, where they're both facing up like this, that means that they're in the up direction. So instead of this one to the left, you're going to pick this one right here as your model. And so once you have that model, you're just going to follow kind of our same system that we did last time. And I'm just going to paste it on this time for the sake of time with this one. So we're going to paste this on, and I'll quickly just explain everything. So, oops, sorry. What you want to do here is just follow the same rules that I mentioned before. So if it's on the dash, so in this case, you got one that's on the dash here, and this CH, or this CH2, CH3 that's on the dash, you want to make sure that you put those on the left-hand side. So if it's on the dash, it goes to the left right here. And again, this compound right here is going to be your left carbon. So how you have H3C here, you're going to write H3C there, because on the left-hand side, and when it's on the dash, you're going to write it backwards to leave it backwards to where the line is going to make sure that it's still connected to the carbon. So on the ones that's on the wedge, you're going to see I have an OH here. So you're just going to put the OH here on the right-hand side. So if it's on the wedge, it goes to the right. And you're going to put OH right there. And on the other side, you're going to put this CH2, CH2, CH3, which is this molecule right here. And it's going to go on the right-hand side. And then you're going to place your compounds up top. So up top, you have a CH2, CH3, which is this one. And then up top, you on the right-hand side, you have a Br, which is here. And you're going to place it as such. So again, this middle circle is your left carbon, and then everything else around is everything that's on the right carbon, and you'll just fill it in following the simple rules. But as always, if this video helped you or your classmates or any friends, feel free to reach out. I know this is one of the more like tougher questions that student grasp with, so feel free to message me directly or write in the comments, and I'll help the best I can. Thank you.